Hello everyone, here is today's problem. Suppose f prime x is e to the power of negative x plus 1 over x squared over x, and the value of f1 equals 0. You are asked to show that for all positive x, fx plus f1 over x equals 0. Obviously, this is a calculus question, but the difficulty lies in, given such f prime, it is almost impossible to get the function f using integration. We let gx to be fx plus f of 1 over x. Then g prime x equals f prime x plus f prime 1 over x times negative 1 over x squared because of change rule. So f prime x minus 1 over x squared, f prime 1 over x. Since f prime x is given by e to the power of negative x plus 1 over x squared over x, therefore f prime 1 over x equals e to the power of negative 1 over x plus x squared over 1 over x. And this obviously equals x e negative 1 over x plus x squared. From here, we divide both sides by x squared. This will be 1 over x squared, f prime 1 over x. And the right hand side will be e negative x plus 1 over x squared over x. And this exactly equals to f prime x. So we see that f prime x is actually equals to 1 over x squared, f prime 1 over x. This means that g prime x, which is f prime x minus 1 over x squared, f prime 1 over x equals 0. So what does it mean? When we have g prime x equals 0. So from what we have just now, if gx equals to fx plus f1 over x, g prime x will be equal to 0. And therefore, gx is a constant. And since it's a constant, we can let it to be g1. And g1 is f1 plus f of 1 over 1. Again, it is f1. And f1 is given by 0. So 0 plus 0 is 0. And therefore, now we know that fx plus f of 1 over x equals to gx and equals 0. And this is what we want to prove. This question is a question that I designed inspired by the following question. That's all for today's lesson. Hope you enjoyed it. I'll see you again next time. Bye bye.